Okay guys, hi and hello. Assalamualaikum warahmatullahi wabarakatuh. I'm Mrs. Sadawiyah. Okay, so for today I will teach you topic probability. Okay, inshallah I will cover the addition law, multiplication law, conditional probability, and expectation. Okay, for the introduction, I will tell you actually we always use the probability in our real life. Okay, for example, when we want to do the outdoor activity, okay, we see the cloudy. Okay, so we will use a probability which is it is a rain or not. Okay, also maybe other situation, maybe we have to undergo any surgery, for example, and then we will ask the doctor what is the probability the surgery success. Okay, so maybe that one is a true example of probability. Actually they have many examples that we will always use in our real life. Okay, so for the probability, okay, what we have to do, what we have to do for the probability, actually I will teach you the basic, but the probability, the keyword, you have to do many exercise, okay, to master this topic. Okay, for the formula, okay, I will use symbol A for even. Okay, probability of even A equal to number of event divided by number of sample. Okay, and then our probability, the smallest is 0. Okay, and then the highest is 1. If you do the exercise and then your answer may be 1.3, so it's confirmed it is wrong. Maybe your answer for the probability is 7.9, for example, so it is wrong because the probability, the range between 0 to 1 also. Okay, so what next I will tell you before I go to addition law. Okay, so for the probability we can use a tree diagram, okay, to help us to do a probability. Maybe we can use a table also. Okay, maybe we can use a Venn diagram to do a probability. So it's up to you, it depends on the question actually. Okay, so I will start with the basic one. Okay, I will give you one example. Okay, we throw a dice. Okay, the question is, what is the probability get even number? Okay, so we have to identify what is the number of event and what is the number of sample. Okay, event is a even number, so we find the even number first. Okay, as you know, a dice that have 6-sided, which is 1, 2, 3, 4, 5, and 6. So for the even number is a 2, 4, 6. Okay, so number of event 1, 2, 3. Okay, so we go to the sample. Okay, sample for this dice, okay, Okay, like I said before, 1, 2, 3, 4, 5, 6. Okay, so number of sample is 6. Okay, so we can find the probability for this question. Okay, number of event is 3. Number of sample is 6. So 3 over 6, so I get 1 over 2. Okay, let's do another example. Okay. For the probability, they have many questions. So maybe I can teach you some of the question also. So for the probability, make sure you do a lot of exercise. Okay? Okay, so the second example. Okay, in company A, they have 1,000 workers. Alright. 750 of them is female. Okay, so this is statement. So please understand this question. In company A, they have 1,000 workers. 750 of them is female. Okay, the question: what is the probability that the workers is male? Okay, I read the question again. In company A, they have 1,000 workers, 750 of them is female. What's the probability that the workers is male? Okay, so the event in this question is the workers is male. Okay, so right now we have to know number of event here. Okay, so in this question it stated 1,000 workers. Okay, 750 is female, so how many is male? 1,000 minus 750, so we got, okay, number of event I change into M. Okay, so number of male workers, so 250. How I get 250? 1,000 minus 750. And then number of sample, 1,000. Sample is all, okay, all the data, okay, in this question. So here is stated 1,000 workers, so we put here. Okay, so how to find the probability? Okay, probability of male workers equal to 250 over 1,000. Okay, so I got 1 over 4. Okay. Alright, so this is the basic of the probability. So maybe I go to the addition law. Okay. Okay, for the addition law, okay, they have 2 event or 3 event or more. Okay, so for the formula of addition law, okay, P A union B equal to P A plus P B. Another one, PA plus PB minus PA intersect with B. Why the formula is different? Okay. So the first one is mutually exclusive. Okay. The second one is not mutually exclusive. Okay, so how to know when we want to use the first formula or second formula? Okay, I will explain by using the diagram first. Okay. So these two events is not related at all. So when it is not related at all, it is a mutually exclusive. Okay, maybe I can give example for the mutually exclusive. Okay, for example, the gender. Okay, so we have either male or female. Okay, so it is not related at all. So for the gender, it is mutually exclusive. Okay, alright, for the not mutually exclusive, okay, maybe I can give example about hobby. Okay, the first event is reading. Okay, the second event is swimming. Maybe some of you have two hobbies, which is reading and swimming, which is here. Okay, so when it is related, okay, when it is related, maybe some of people like reading, like swimming, so it is not mutually exclusive. So this is how to differentiate when we will use the mutually exclusive or not mutually exclusive. Okay, all right. So maybe I give example. Okay. Okay, in a hospital, they have 10 doctors and 15 nurses. Okay. 5 male is doctors and 10 female is nurses. What is the probability? The staff is nurse or male. Okay, so from this question, okay, so this is the keyword or. So when the question use a or, so this is a one keyword that we know it is a addition law. Okay, if multiplication law, The keyword is and. Okay, this is one way how to differentiate when we want to use the addition law or multiplication law. Okay, back to the equation. In a hospital, they have 10 doctors and 15 nurses. 5 male is doctors and 10 female is nurses. What is the probability that the staff is nurse or male? Okay, so from the last statement, the question 1, the probability the staff is nurse or male. Nurse or male. Okay, so right now we have two formula here. Either we identify this question is a mutually exclusive or not mutually exclusive. So for help us to identify, maybe we can draw a table. Okay, so this one is a doctor's. Okay, so this one is a nurse. So this is a total. Alright, so for the gender, male, female. Okay, from the statement here, 5 male is doctor. Okay, so male, doctor, 5. And then, and 10 female is nurses. Okay, so female, here, 10. Okay, look at the first statement. They have 10 doctors. So here is 5 doctors for the male. So for the female, it's another 5. Okay, so for the nurse, they have 15 nurses. So 10 of them are female. So for sure, for the male is 5. To make total 15 nurses. Okay, so nurse 15, doctor 10. Okay, so total here is 25. Okay, because 10 doctors and then plus 15 nurses, so 25. Okay, so here 10 male and then 15 female. Okay, so when I see this table, I can see the relation. Male and the doctor, male and the nurse, female and the doctor, female and nurse. When it is half a relation, so it is not mutually exclusive. Okay, not mutually exclusive. So I will use this second formula, which is Pn plus Pm minus Pn intersect with M. Okay, probability of nurse. Okay, total nurses is 15. Okay, over. Okay, don't forget probability is about number of events divided by number of samples. So number of samples, we have to add up 10 doctors and 15 nurses, so it will be 25. Okay, so I put here. Okay, plus probability of male. So look at here, male 10. So 10 over 25. 25 because it is a sample. Minus in nurse and male. Nurse, male. Okay, look at here, nurse, male. Okay, so 5. 5 over 25. Okay, so 15 plus 10 minus 5. So I got 20 over 25. So I get here 4 over 5. Okay, so I repeat. Okay, first of all, to solve this question, you have to find either this question is mutually exclusive or not mutually exclusive. Okay, to help you, okay, you draw a table and then you check either they have a relation or not. Okay, for this question they have a relation, male and doctor, female and doctor, male and nurse, female and nurse. So when it have a relation, so not mutually exclusive. Okay, so I show you the next example for the mutually exclusive. Okay. Okay, so this is the example. Okay, I read the question. In an ice cream shop, they have 2 types of chocolate flavor, 1 type of mint flavor, and 3 types of Oreo flavor. What is the probability that the ice cream is chocolate or Oreo or mint flavor? So the question is the OR. Okay, so this is the hint. One hint, we will apply the addition law. So the problem is we want to use a formula for mutually exclusive or not mutually exclusive. Okay, what say you? Okay. Okay, for this question, it is a mutually exclusive. Why? Because the flavor is not related at all. This is a chocolate, they have a mint, they have the Oreo, and 3 types of flavor is not related at all. They have no chocolate mint, they have no chocolate Oreo, they have no mint Oreo. So stated in this question is chocolate, mint, and Oreo. So it is not related at all. Okay, so for solve this question, okay, what is the probability? So the symbol of probability. Ice cream is chocolate, so I use C for chocolate, and then O, union, Oreo, or union, and then mint. Okay, so I'll start with chocolate. So chocolate, they have 2 types of chocolate flavor. So 2 over, what is number of sample? So we have to add up 3 types of flavor, which is chocolate, mint, and also Oreo. So 2 plus 1, 3, 3 plus 3, 6. Okay, so number of sample is 6. Okay, plus Oreo. Oreo, they have 3 types of Oreo. So 3/6. Okay, plus for mint flavor 1. Okay, so 1/6. So 2 plus 3, 5. 5 plus 1, 6. So 6/6 is 1. Okay, so this is the maximum figure of probability. Okay, probability cannot more than 1. Okay, so for the addition law, okay, so please remember they have 2 types, which is the mutually exclusive and not mutually exclusive. Then you read the question properly, either the question is mutually or not mutually. Okay.